down in here. Okay, the sine is this piece of it. The cosine is this piece of it. And the x-axis gives us the bottom of it. So you need to find your limits. So what are our limits? Well, we have one limit over here. The limits are the places where the curves intersect. Okay, you have one over there, you have one over here, you have one out here. And an easy way to do this is, you know that you have three functions. You have sine of x, you have cosine of x, and you have y equals 0. That's the x-axis. All right? So what you do is you make every possible combination equal to each other. So you can say sine x equals 0. Okay, that means this one here, where sine hits the axis. Well, you can just take the arc sine of both sides of this. Okay, I took the arc sine of both sides. Inverse trig functions cancel each other out. That gives me x equals, and the arc sine of 0 is 0. You know, if you key that in on your calculator, let's shift sine. Yeah, arc sine of 0 is 0. So that gives us our first point. Our first limit is 0. Our second limit, we're going to say cosine x equals 0. Okay, that's going to be this one out here. And we're going to say, okay, take the arc cosine of both sides. And this time you get x on the left side, but you're going to get pi over 2 on the right side, or 90 degrees, depending on how your calculator is set up. So let's double check that. Yeah, you get pi over 2. So that's one of our other limits. Now, what's our last limit? Well, that's what I was starting to do here. I said sine equals cosine. I divided both sides by cosine. That gave me tangent. What do you think you would do for this? To find out what x is.
Arctan?
Yeah. Take the arctan on both sides.
Yeah.
And what you wind up with is x is pi over 4. So now you can take your area. You're going to do one integral for this piece of it. Then you're going to do another integral for that piece of it. So you've got an integral from 0 to pi over 4, and another one from pi over 4 to pi over 2. And you have to look at which curve, which function you're doing for each one. So that's the key to that. And all the area problems work exactly the same way.